Assalamualaikum warahmatullahi wabarakatuh. My name is Haris, and today I'm going to represent my team in the assignment of noise filtering in audio signal. Okay, so this is the list of my group names: Abdullah Lip, Zulhusni, Daniel Nabil, Iman Hakim, and also me, Haris, Aziz Hamzah, and Haziq Shafi. Okay, so the objective of this assignment is to analyze corrupted audio signal in time and frequency domains, design and implement a digital infinite impulse response IIR filter, and conduct system stability and characteristic analysis, and lastly to verify and evaluate filtering performance. Okay, now let's hear the original corrupted signal.
0125.
Okay, from this audio signal, we know that it consists of voice and sequence of numeric digits 0, 1, 2, and 5. But this audio is heavily corrupted by high noise and also distorted by loud and sharp background, hiss, static, or buzz. Okay, after inputting the audio inside MATLAB and doing the plotting, we can see that the signal in time domain, it is very jagged and very not smooth throughout the signal. This indicates that it is corrupted by a high frequency noise. So when we put it inside original signal spectrum, we can see that uh, the signal have a ripple at the end of the file. Okay, it show and it's very jagged. It's very not stable. It show that it is corrupted. Okay, so now the parameter for the filter. Okay, so we choose the filter type of low pass filter, which can block high frequencies and allow low frequency to pass. And the cutoff frequency is 0.3, which indicates 0.3 pi rad per sample, which means that after 0.3, it's gonna cut off and gradually attenuate to 0. And the filter order is 6. Okay, so after the audio go through a filtered signal and we plot it in time domain, we can see that it is less jagged and more smooth throughout the audio file here based on the graph. Okay, and okay, for the frequency spectrum plotting, we can see that the graph after 0.3, it gradually go down and attenuate to 0. Okay, based on the graph here, and it's become almost very smooth. Okay, so we do poles and zeros analysis to see the stability of the system. And based on the MATLAB code before, this is the plotting for the poles and zeros. And the six X mark here show that the sixth order of the system, and all the poles is inside a unit circle of 1, which indicate that the system is highly stable. Okay. Okay. Now we do a filter impulse response. Okay, after the audio is filtered and we do the impulse response, we can see that it is the same. We have the same result where after 0.3 is being cut off and gradually, okay, goes down from the amplitude to 0. Okay. This graph demonstrate that through the continuous tail of alternating rate step, which fluctuate and decay infinitely over time rather than stopping abruptly.
0125.
Okay, this is the final filtered sound, and this sound proof that the audio file is proof that we successfully using an IIR low pass structure that to implement and isolate the real human speech envelope from unwanted high frequency static and resulting in a clean, highly intelligible voice crack. So based on this final voice, final audio file, we are successfully finished the assignment. Thank you.